In the last class, we discussed the electrochemical cell and its construction and the working of it. Right? So there we used the salt bridge. The electrochemical cell consists of a salt bridge. Today we are going to discuss what is the role of using the salt bridge and how it operates. Now, the salt bridge, it is a U tube which is filled with the inert electrolyte, right? And the concentrated solution of it is made in gelatin or agar solution, right? Just have a view in the electrochemical cell or generally a Daniel cell. Now, as we discussed last day, that the Daniel cell consists of two half cells. One is known as the oxidation half cell, right? And there is the reduction half cell. This is the oxidation half cell and this is the reduction half cell. Now here the oxidation half cell, what happens? There is oxidation taking place and the zinc ion from the zinc rod will come into solution, that is matter is coming into a solution, and there is accumulation of electron here, zinc acting as an anode here, right? The electrons are flowing from the zinc rod, right? When the key is being open or we can just switch is on, right? So since the matter is coming into solution, you can see in the diagram here that the thickness of the zinc electrode is decreasing, right? Now when the key is open, right, that time what will happen? The electron will flow from zinc to the copper electrode, right? Here we are terming it as the cathode here. Now in the copper electrode, you can see here that the thickness of the copper electrode has been increased. So why it is so? Because electrons will flow from the external circuit and they will come into the solution through this electrode, and the solution we will have copper ion. They will accept those electrons and they will accumulate on the electrode as a copper. Gradually what will happen? The thickness of the copper electrode increases as it is visible in the diagram also. Now the electron flow is from anode to cathode and current flow is from cathode to anode. Right. Now we have it. What is the use of using this salt bridge? This is the salt bridge. Right. So as I said earlier that the salt bridge, what it is an inverted U tube filled with a concentrated solution of inert electrolyte in gelatin or in the agar and agar. Now here we are using the word inert electrolyte. Now the inert electrolyte are those electrolyte which do not get involved in the cell reactions, right? Until and unless the demand will be there, they will be remaining as a inert there. Second, the mobility of the ions, right? The cation and the anion will be same there. That means as I have shown the diagram, I have taken here KCl, right? The mobility of the K positive and the KCl negative, the mobility of ions is same, right? This is the characteristics of the inert electrolyte. Now what will happen as the time passes on, right? Gradually what will happen, what will be observed, that the thickness of the two electrodes is going to change. Zinc will decrease in thickness whereas copper electrode is going to increase. Second, what will happen when the cell has run for a long time, then the magnitude of current is going to decrease. Right. Now why it will be so? So it will be so why? Because gradually what will happen? There will be accumulation of the zinc ion around this zinc electrode. So what will happen? The further oxidation of zinc metal into zinc ion will be slowed down. That means the positive potential, or we can say the positive layer of zinc ion will be formed around the electrode, and they are going to repel the new coming zinc ion, right, into the solution. As a result, what will happen? The flow of the electron will be affected, right? Now coming to the cathode side here, what will happen here? The copper ion, they are accepting the electrons, two electrons, and they are accumulating in the electrode. Now what about the sulfate ion? They will remain as it is. So there will be the accumulation of the sulfate ion, that is a negative charge around the cathode. Right. Now when the electrons will be flowing through the external circuit, they will coming into a solution. What will happen? That electron will get the repulsion from it, and hence the, we can say, the magnitude or the speed by which they were coming into the solution is going to reduce. So gradually there will be the magnitude of current is going to decrease. Now to overcome this, right, we are using the salt bridge. Now come to the function of it, function of salt bridge. The first function is the salt bridge completes the electrical circuit, right? Externally, the two electrodes are connected through the copper wire, and internally the two solutions are connected through the salt bridge. So the salt bridge is going to complete the electrical circuit. Now the second one, this one, that it maintains the electrical neutrality of the two half cell solution, right? So electrical neutrality of the two half cell reaction, until and unless there was we can say overcrowding of the ions. Before that, this half cell was a neutral half cell, and this was also neutral half cell. Both half cells were neutral. But as the current is drawn, as a cell works, what will happen? There is accumulation of the positive ion. Right. Now here the accumulation of the negative ion. So the neutrality is going to get disturbed. Right. So to overcome this, the salt bridge, right, the mouth of the salt bridge is been plugged with a cotton wool, right? So when there is a positive layer accumulation, what will happen? The KCl, I have taken the example of KCl, you can take KNO3 or ammonium nitrate also. So the here, to just wipe down or to just remove this positive layer, what will happen? The negative ion, just opposite to this zinc ion, will come into the solution, right? So you can see here that K plus, it is there, Cl negative coming here. In the same way, Cl negative ions will be moving toward this half cell, right? Oxidation half cell. So what will happen here? The Zn2 positive ion, for one Zn2 positive ion, 2 chloride ion will be coming here from the salt bridge to form zinc chloride, and it is going to settle down. So gradually what happened? The zinc ion which are being accumulated are going to settle down as zinc chloride. Now on the other side, reduction half cell, we have got the layer of sulfate ion, negative ion here. So what will happen? From the salt bridge, K positive, right, which is a positively charged ion, will make its move. You can see from here it is making its move toward the reduction half cell. Here also K positive ion coming to the reduction half cell, right, and this K positive will just react with the sulfate ion SO4 2 negative, right, to give K2 SO4. So here the potassium sulfate will form and it is going to settle down, right? So in this way, what will happen? The ions which were surrounding the electrode are going to remove, and it will again bring the electrical neutrality of the two half cell.